Welcome to G Fun Facts Online. Have you ever looked up at night and seen our familiar silvery moon transformed into a haunting, fiery red orb? This celestial event, often called a blood moon, isn't a sign of doom, but a breathtaking display of orbital physics. Today, we're going to unravel the science behind this celestial ballet, from the precise alignment of the heavens to the atmospheric trick of light that paints the moon red. The foundation of any eclipse, including a lunar one, is a concept called syzygy. It sounds complex, but it's simply a straight-line alignment of three or more celestial bodies. For a blood moon, or total lunar eclipse, to happen, the Sun, Earth, and the Moon must be in syzygy, with Earth perfectly positioned in the middle. This can only happen during a full moon, which is when the Moon is on the opposite side of Earth from the Sun, allowing us to see its fully illuminated face. But this brings up a logical question. If there's a full moon every month, why isn't there a total lunar eclipse every month? The answer lies in the tilt of the moon's orbit. Imagine the Earth's orbit around the Sun as a flat, level plane, like a giant celestial vinyl record. This is called the ecliptic plane. The moon's orbit around the Earth isn't perfectly flat on this record. It's tilted by about 5.1 degrees. Because of this tilt, during most full moons, the moon passes either just above or just below Earth's shadow, missing it entirely. So what makes an eclipse possible? The key is where these two orbital planes cross. There are two specific points where the moon's tilted path intersects the Earth's ecliptic plane. These points are called the lunar nodes. Think of them as celestial gateways. An eclipse can only happen when a full moon occurs at the same time it's passing through one of these nodes. Only then is it in the right position to travel directly into our planet's shadow. This cosmic timing is what makes lunar eclipses relatively rare. To make it even more interesting, the line connecting these two nodes slowly rotates, a process called precession, over a cycle of about 18.6 years. This means the opportunities for eclipses come in what are known as eclipse seasons, which happen roughly every 6 months. Now, let's talk about Earth's shadow. It's not just one uniform area of darkness. It has two distinct parts, the penumbra and the umbra. The penumbra is the faint outer part of the shadow. If the moon passes only through this region, we get a penumbral eclipse, which is so subtle you'd likely not even notice the dimming with your naked eye. The real show begins when the moon enters the umbra. This is the dark inner core of Earth's shadow, where the sun's direct light is completely blocked. A total lunar eclipse is a slow, gradual process that unfolds over several hours, and we can break it down into a few distinct stages. First, the penumbral eclipse begins as the moon enters that faint outer shadow. The change is barely perceptible. Next, the partial eclipse begins. This is when things get noticeable. The moon starts to move into the umbra, and it looks like a dark, perfectly curved bite is being taken out of its surface. Then comes the main event, totality. The total eclipse begins when the entire moon is swallowed by the Earth's umbra. Direct sunlight is now completely cut off. The point when the moon is closest to the center of the umbra is called maximum eclipse. This is often when the moon appears its darkest and most vividly red. After reaching its peak, the process reverses. The total eclipse ends as the moon starts to creep out of the umbra, and a brilliant sliver of its surface is once again hit by direct sunlight. The partial eclipse ends when the moon has fully exited the umbra, leaving it only in the faint penumbra once more. Finally, the penumbral eclipse ends when the moon completely leaves Earth's shadow, returning to its usual brilliant, full state. The duration of totality itself can vary quite a bit, from just a few minutes to nearly an hour and a half, depending on how centrally the moon passes through the umbra. But why the red color? Why a blood moon? This is where Earth's atmosphere becomes the star of the show. During totality, while the Earth is blocking all direct sunlight, our atmosphere acts like a lens, bending some sunlight around the edges of the planet. As this light passes through our atmosphere, a phenomenon called Rayleigh scattering takes place. This is the same reason our sky is blue. The shorter wavelengths of light, like blues and violets, are easily scattered away by air molecules. But the longer wavelengths, the reds and oranges, are less affected. They pass through the atmosphere more or less intact, get refracted or bent towards the moon, and illuminate its surface. In a very real sense, during a total lunar eclipse, you are witnessing all of the world's sunrises and sunsets being projected onto the face of the moon at once. The exact brightness and shade of red can also change from one eclipse to another. Astronomers use a 5-point system called the Danjon scale to classify the luminosity. A 0 on the scale is a very dark, almost invisible eclipse, while a 4 is a very bright, coppery orange eclipse. The color depends on the state of Earth's atmosphere. If there's a lot of volcanic ash or dust in the air globally, it can block more light, leading to a darker, deeper red and a lower rating on the Danjon scale. Long before we understood the orbital mechanics and atmospheric physics, this sudden, dramatic reddening of the moon sparked fear, wonder, and a rich collection of myths. In ancient Mesopotamia, a lunar eclipse was interpreted as a direct attack on the king. They would even appoint a proxy king to take the brunt of the celestial anger, who would then be sacrificed to protect the real ruler. The ancient Incas believed the red color came from a celestial jaguar attacking and eating the moon. They would shout, shake their spears, and have their dogs bark at the sky to scare the jaguar away. For ancient Egyptians, the culprit was a giant sow swallowing the moon for a short time. Eclipses also hold deep significance in various religions. Some interpretations in Christianity have linked blood moons, especially a series of 4 in a row called a tetrad, to biblical prophecies about the end times, particularly from the book of Joel. A recent tetrad in 2014 and 2015, which coincided with Jewish holidays, brought these ideas back into modern discussion. In Hindu mythology, the demon Rahu is said to swallow the moon, causing an eclipse, and the event is often considered inauspicious. In contrast, Islamic cultures generally view eclipses not with superstition, but as a demonstration of God's power and a time for special prayers. Many Native American traditions also have profound spiritual beliefs about the event. The Hupa and Karuk tribes of California, for example, believed the moon was wounded or bleeding from a battle with the sun, and their shamans would perform healing rituals to restore its health. So the blood moon is far more than just a pretty sight. It's a perfect storm of celestial mechanics, a lesson in atmospheric optics, and a mirror reflecting humanity's long history of trying to make sense of the cosmos. It's where the clockwork precision of the universe intersects with our own capacity for storytelling, science, and awe. The next time you see the moon blush red in the night sky, you'll know you're not just seeing a shadow, but a projection of all of Earth's sunsets and sunrises, a phenomenon that has captivated our ancestors for millennia and continues to connect us to the grand, intricate dance of the heavens. Thanks for tuning in to G Fun Facts Online.